Ladies and gentlemen, hello and welcome to the part 2 of our KEMET webinar on the new Volkswagen 8088 Standard. My name is Alexander Nebel and I will moderate the webinar today. We are very pleased that you find the time to join our webinar. Presenter today is again, like the last time, Axel Schmidt, our European Senior Field Application Engineer for automotive customers. Hello Axel, thank you for presenting again today. Please tell the audience shortly about your role inside KEMET, and then you can directly start your presentation.
So my name is Dr Schmidt. I'm Senior Field Application Engineer in KEMET Electronics since now 19 years. And I'm in charge of the German car OEMs. That means besides Volkswagen, Audi, Porsche, also BMW and Daimler. And yeah, I'm more focused on the technology side, on how to use our products and how we can bring them into the automotive things. And again, in the last session, the part 1 was a couple of weeks ago, where we introduced the Volkswagen 8808, which is something that's going around, and we want to give you a little bit insight. So what's behind the specification? So why people are asking for that, and why is that important for us? Also, we highlight a little bit the changes to the previous version. And it's the section that refers to us in this Volkswagen standard is the usage of the tantalum and polymer. And this will be the main topic today. What are the restrictions? What are the limitations? Is there anything you need to consider when you start designing our parts? And the biggest portion of that is also, of course, MLCC, because that's the highest quantity that's running, and you find it in nearly every electronic unit. This MLCC section splits up in more or less 2 sections: the component requirement, application requirement. And in the application requirement, then we talk about flexible termination, a little bit about ESD, and about the terminal 30 application, which is everything that's connected directly or indirectly to the battery, so the plus pole of the battery in the case. What is Volkswagen 8808? Again, it's a standard that's not an official one, it's a legal one. It's really published by the Volkswagen Enterprise in their online portal. And it's about component requirements, qualification requirements, application requirements. That's the major outline. Beside that, it's a collection of rules. And I think they collect experience that had in the past and try to avoid any mistake again. Because last time we get some questions, so we are not allowed to hand out any digital or paper copy of the specification. So that is something you need to ask to be a certified supplier of Volkswagen, and then you get access to their online portal. And from this online portal, you can download the German. And in the meantime, since last Friday late, we also have an English version, but I wasn't able to include it until this morning. So the reason why you are not get a paper copy from us or a digital one is simply that you have to use always the latest online version. So Volkswagen want to make sure that all of their suppliers have the latest revision, because sometimes there are really major changes. And if you're working on the old stuff, they get a lot of unnecessary discussion about that. Volkswagen itself supports the marketing approach about this term Volkswagen 8808. It's a kind of win-win situation, because that is somehow similar to, you probably know from combustion engines, the oil specification. There's also something. So in general, if you buy something, or if you get KEMET product with Volkswagen standard, according to Volkswagen standard, normally it's enough to refer to that. But there are a lot of R&D people out. They want to know, so what's behind, and so what I need to take care of, and then how can I fulfill the standard? And that's what's about today. What are the changes? So the first one was in 2013, then there's a change in 2015, and then the latest one was now. In the old one, tantalum was more or less not allowed. And that's not really true, because that's not allowed on the terminal 30. Right now, it's explicitly allowed to use a tantalum capacitor up to a 2.5 watt rule. And what that is, I will explain later. Polymer capacitor was not mentioned, so it's also tantalum. So we say tantalum polymer and tantalum standard or classic or MnO2. So that this tantal is the one we used the last decades. polymer capacitors, we try to avoid a little bit the word tantalum because it's a little bit on a bad reputation, even the tantalum was not the guilty part. What's not mentioned, so was a lot of uncertainty about how can I use this technology, which gives you definitely some improvements. And so now since 2015, we visited Volkswagen, and now we get that on the specification, explicitly mentioned tantalum polymer. And they have a 5-watt rule in terms of the 2.5 watt compared to the tantalum with MnO2. Today, not a lot on terminal 30, that's bad, but we're working on that, and that's what's coming probably with the next Rex release. For MLCCs, there are some restrictions in terms of case size. So in former times, you should not use everything that's bigger than 1210. So 18, 12, 22, 20, 22, 25 wasn't really allowed, and not very famous scene. And so they actually they changed a little bit to have a minimum case size and a maximum case size. So right now you can use everything. So 0805, 1206, 1210 is what you had to use in at least on the terminal 30 clammer battery. Also, the rated voltage is up to 100 volt, and I come to that in a few slides more in detail. Then they have this extreme flex term testing that we had in the past. So we weren't really able to offer a broad range of this capacitance values because this 2 times rated voltage acceleration was a big roadblock. So nobody, even also the other suppliers, the bigger one, at least the Japanese, and wasn't really sure about how can we handle that, because the maximum we tested typically is 1.32 times, but not 2 times. So right now it's reduced to 1 times rated, which will relax the situation a little bit. And also from this 1,000 hours testing, you can go down when you increase the temperature, you can go on to less testing time. That means you go to 96 or 264, which allows you to test more parts in the same time. I was a little bit surprised, honestly, but now it's fact. So we can use high voltage MLCCs. Wasn't the old spec not mentioned. So right now we have something floating electrode, 1,000 volt rated plus KPS. And or you can use a floating electrode plus flex term. And what that is in detail, I'll let you know later. And then Y-caps was also not mentioned in MLCC. So right now we have a rule for that, 2 capacitors in a row. Was the rated voltage should be 2 times the battery or the system voltage level. So that's in short an overview about the changes. And now let's go to the polymer thing, which was a long way for us. We did a lot of tests and to persuade Volkswagen that they accept this. Unfortunately, there's still some constraints with the usage on the battery. We don't see that because I think the boardnet is more or less clear. We do our homework, but anyhow, right now, until today, we are not allowed to use polymer and tantalum capacitors on the terminal 30. But we can do everything else. So what's not on the battery line? So a tantalum capacitor with MnO2 can be used when the current path is limited to 2.5 watt, or the the inrush current is lower than 10 amp. We have a similar rule for polymer capacitors, but which higher values. So the same power for the current path is up to 5 watt, and the inrush current is lower than 20 amp instead of 10 amp for MnO2 parts. And the robustness over life has to be proved, and therefore we have a great tool that we can share with you. So the question is tantalum or polymer. I think the clear direction of the market is in terms of polymer, but there are at least 2 applications where the tantalum capacitor MnO2 matters or has some advantages compared to the polymer capacitor. So one is the high temperature. So we launched a year ago T599. So we have polymer up to 150 degree. But still a lot of combustion engine out in the market, and still also the hybrid things that have still a combustion engine. So the typical application, for example, an oil sensor running at 165 degrees C, that's probably something you go for MnO2. For the second good argument is low leakage, low voltage, mainly low leakage. Here is the application example, the TPMS, the tire pressure monitoring system. So where we have the whole unit in a wheel, and then it converts some mechanical energy into electrical one and measures the tire pressure and send a protocol wirelessly to the body electronic. And here, of course, the leakage current matters, and that's where MnO2 is ahead on. And with the low voltage and low current consumption, there's no risk having this bad ignition failure mode on that. And all the rest, we highly recommend to use polymer. That's where the market is going. That's where we improve and eliminate all the disadvantages of the other technology. We have recently launched, and recently means last week, T597. So T598 is what we have already some years ago. So that's the polymer in automotive. Then we have T599, that's the 150-degree version. And then T597 in between is a very small case size. That means a drop-in replacement where you can substitute 0805 and 1206 capacitors over the polymer capacitors, high capacitance. High capacitance means 10 microfarad and up. All this part are automotive qualified. So ACQ200 applied, and then we have done a lot of tests to prove the reliability and lifetime, and we can really bump you with data on that. When you use the parts, one of the biggest in the past for the MnO2, which put them in a bad position, was the D-rating guideline. That's somehow a little bit tricky. In the meantime, it's more graphical. So still consider or take care about the D-rating above 105 degrees C. So if your application temperature, your ambient temperature plus self-heating is above 105 degrees C, then you need to consider certain D-rating thing. That means you should use higher rated voltage parts on that. So coming to the 5-watt rule, and that's similar to the 2.5 watt for MnO2. So what it means, it's power is of course current multiply current times voltage. So that means for USB 2.0, for example, where you have 5 volt, 1 amp, that's 5 watt. That's where you can go for. So everything on the secondary side that has that stuff can use the polymer capacitor advantages. Also, because they talk about power, my original proposal was about current, but they use the power rule. Could be also 1 volt 5 amp if you go to auxiliary devices and supporting GPUs or ZPUs. So everything was on a low level. So again, the product of voltage times current should be less than 5 watt. That's the story here. So the robustness over life is, sorry, I need to put in power, otherwise Alex, can you see still the screen?
I can see the wrong screen. I see the presentation mode, presenter mode.
Okay, I'm sorry for that. So, you see the right screen? It's okay now?
Yes, now it's correct.
Okay. So in this catalog for T598, T599, and T597, we give you a page where you can actually calculate lifetime. And lifetime is based on the PV equation, Popovic-Vasquez. So we have this inverse power law combined with Arrhenius, and then it gives you, combined with the test time we did, it gives you a certain lifetime. So important is for you, you have to know your ambient temperature plus self-heating, and of course in the application voltage compared to this. We call it category voltage, but actually category voltage is up to 105 rated voltage, and above the 105 degrees C, you need to have derate your voltage and go with lower ones. And then that's very common in the automotive industry, submission profile. So we got from you or from our customers actually a emission profile, and then we calculate for each temperature slot the fit rate, and then we can come up with a total fit rate and can provide it to you, or we can easily provide you a tool that will come up in the engineering center, in the near future. This is actually the T597. So momentarily, the focus is on the S case because most people want to have much capacitance as possible. We're working and we have already sampled, but not in mass production, the P case. So you see, you can hear 22 microfarad, 6.3 volt, or 47 microfarad in a 1206, 6.3 volt. This, and we know a lot of application where people choosing a 2220 or 1206, 1210 with 25 volt and 10 mic and 22 mic because they have about concerns about the DC bias and aging effect. So that was last year, 2 years ago, caused a big issue in the market, or at least at one of the big suppliers. So here with polymer capacitors, there's no derating, there's no there's no aging and no DC bias effect that need to apply. So you got 47, you got 47, and not 47 nominal, and application you have less than 50 or 40% of that. Oops. This is, so sometimes I put that in because it's a nice transition to the MLCC section. So we got recently, so what about when somebody happens by accident, use commercial parts in terms of automotive MLCCs, and what is compared to polymer? So polymer is not really a pretty new technology. It's more than 20 years old now. It started in the end of the 90s, but was not used for automotive. But of course, we have a lot of data for that. If you look on that, if somebody really placed by accident commercial MLCCs and you ship 1 million pieces, so your return rate will be 46 for commercials, which is 158% related to automotive MLCCs. Here is set to 100%. That means 100% means 29 pieces. And if you use for the same application, same condition, application condition, automotive polymer, you end up with 4 pieces, which is only 40%. And that's, I think it's a great message, and it's really highlight to use this technology, because also the automotive guys understand that's very important. Don't place dozens of ceramic chips in parallel if you can have the same solution with 1 or 2 polymer capacitors. And actually that was the section for polymer. Now head over to MLCC. So the first thing, section 9 is about capacitor. 921 is about MLCCs, and here I actually found a nice, that's the English version right now. So the story is here, you have to have at least 100 volt on the 12 volt electrical system. So that means on the battery, terminal 30, 15, 50, 87, and so on. So 100 volt is a must. So what are the possible solutions if you use, you need, for example, 10 microfarad at the terminal 30, and you have to use 100 volt rated for MLCCs. So, and then of course they require safety mechanism. So that means the typical flex term, open mode, so the going keywords around, floating electrode and KPS. So, so what you can use is actually you can use 2 times the standard part, 100 volt, and then we offer you 2.2 mic in a 100 volt automotive. So you put 2 in series, you end up with nearly 1 microfarad. So you need 10 microfarad and you need 10 pieces. Very simple. Then you have the other safety mechanism, that's open mode and KPS. And KPS is the version with the metal bracket. So open mode, you offer you a 1 microfarad 100 volt open mode in 1206, 1210, sorry. So you also 10 pieces roundabout, and we can do a 2.2 microfarad 100 volt part in a KPS, and then you need only 5 pieces. Or you can use 2 times flex term, which we currently offer 470, will be 560, and we'll see if we can get into the microfarad range. So for that, of course, you have to use 10 pieces as well. For safety, so there's another exception in that rule. So if you have anyhow some voltage clamping component in the past, and that could be a resistor or it could be a TVS diode, then you're allowed to lower the rated voltage. And I had a call with Volkswagen last week about, so what is, so can I use 25 and 16 volt? No, you actually go with 50 volts. So that means If you have a move the varistor inside, then you can go with a 1210 10 microfarad 50 volt part, same as you have a TVS diode. But then you have to apply oscillograms and let the Volkswagen guys know that this active clamping is really working. So it's not just I have a TVS diode. I really need to prove that by an oscillogram that the voltage will be cut off on an uncritical level. So going a little bit more on this, so the 100 volt is mandatory, so you can clamp that. So that's a trade-off, and that is, I think, what KEMET can help here. So you can also, for the 10 microfarad, so if you look on this portfolio, what we can offer right now, it's at 0805, 1206, 1210 is green. So we have COG, X7R, you get your X7R open mode, OM, so you get X7R floating electrode, or you get X8R, which also is available at 100 volt, but X5R and X8L are out of scope. So all this nice 100 microfarad, 6.3, 1210 pieces are not part of this game anymore. So the trade-off, for example, will be if you use 5 times 225 100 volt, or you have 2 times 1210 475 50 plus a TVS diode, and you know, this is the trade-off between, so how many you pay for the TVS diode and how many you pay for, let's say, if your application run in 100,000, so you need 200,000 4.7 microfarad 50 volt capacitors, or you go with the other solution and you buy 500,000 1210 225 100 volt parts. So probably you can negotiate a different price, and then you see if the TVS with the lower ceramic volume matters, or you go with the higher ceramic volume and drop off the TVS diode. But that is something where KEMET sales and the FAE team will greatly help you on that. That's for the guys who like this more in a graphic way than in a table. So I put the COG, X7R, X7, OM, open mode, floating electrode, and X8R. And on the y-axis, you see here the available capacitance values in nanofarad. So there's another, the minimum case size is 0805, which I already mentioned. And now there's another exception. So if you have an active error detection, that means you have some kind of device that is monitoring the current, and let's say normally your application consumes, let's say 100 milliamp, and then probably it sucks, you know, 2 amps or 5 amps, and then you can disconnect your application from the board net. If you have something like that, then you can disregard all these rules before. So that's fancy rule, but I will like it. So if you have anything like as an active device plus semiconductor plus diode, but if you have that anyway, then you can get rid of all the other rules. Another topic, another section within the Volkswagen 8808 is about ESD. So for us, surprisingly, it's only a 603 case and bigger. So we developed with I think 3 or 4 years R&D time. So an 0402 that passes the ACQ 200. But now, so they restrict everything to 0603 and bigger, so 0805. But typically you try to use the smallest case size that's available or that's fit in your application. The minimum capacitance requirement is about 10 nanofarad. And then they have a rule that's similar to our insulation resistance rule, so microfarad. But they call it voltage multiply or voltage times capacitance, and that's 2,200 volt per nanofarad. What it means is, so you can use 100 volt multiply with 22 nanofarad, you got 2,000 or greater equal than 2,200 nanofarad. Or you can use 50 volt, 47 nanofarad, gives you also a value that's bigger than 2,200 volt nanofarad. If your application, because this has some effect on your data, on your pulse, on your lines, so if you really need smaller capacitance values, then it requires a TVS diode in parallel. Or your parts or the ESD parts are according EN 61000-4-2. But so at least in my horizon, nobody offers that for automotive. I don't know why, but I think it's a very stringent test, and I haven't the details yet. But as soon as I know something more, then we can set up training about that one. Again, we have that complete ESD portfolio in X7R and COG, commercial and automotive grade, up to 200 volt DC. So if you look on that portfolio, then you see it when you lower down to 0603, and then we have this 10 nanofarad, and then we have this 2200 volt nanofarad rule, and then you see it's only about this green area here where I go. So these are the values you can use standard KEMET components, but also from our competitors. If you go outside this area, you have to use a TVS diode in parallel. Okay, so coming to the biggest thing, I mean, these are rules and it's kind of how to use in application the component. And then the biggest portion or the biggest part of testing was FlexTherm, and that was where the I think the oil specification comparison is coming from. In this section, you have to use soft termination coding 80808-2, Appendix A, qualification of MSSC with soft terminations. And that is what we had offered also in the past since 2 or 3 years. And it's very important if you order that you add the C-spec and this red rectangle. So the 3316 and the 3317, because otherwise you get something but not parts that are according. So the test sequence, or what is the difference to the ACQ200? The test sequence is very harsh because we have to use the same part for all testing. If you test according to ACQ200 and you test 85 tests, you take 77 pieces. Sometimes you take 77 pieces, 3 batches, and then after that you scrap that. You don't use it for bending test afterwards, or you don't use it for thermal cycling. And here the Volkswagen requires everything has to go through the sequence. So we start with 100 pieces, then we mounting PCB, then we do electrical measurement, we do bending test, the flex test, 5 millimeter, then we do again electrical measurement, then we do thermal cycles, so 1000 of them. 30 minutes each temperature, minus 55, 125, and a very short transition time. Then we have this very, very tough temperature humidity bias, THB testing with 85, or now we can vary a little bit about that. Another bending test, another flex test, 5 millimeter. And then a short THB, another temperature humidity bias test for 24 hours. Why? I mean, this allows the humidity penetrate into potential cracks, and then it will lower the insulation resistance. And after those 24 hours, we do another electrical measurement, capped dissipation factor or tangle delta in Europe, and the insulation resistance. And then we have to do certain 2 times cross-section pictures in the beginning and the end, and we have to provide the microscopic pictures and the test data to Volkswagen to get approved on that. In the past, we had not very much data about this 2 times rated voltage in the THB test. So right now, they mitigate a little bit the condition. So we're waiting for some final confirmation from Volkswagen, and then we do start testing. So if you need flex thermal coding Volkswagen 8808 and it's not in the current roadmap, then you probably need to wait another 6 to 9 months until that's available in the market. So the test challenge here is, you have 1 MSSC per PCB. That's the major difference to other tests we did in the past. So if you see on the kind of test chamber, so we have only 20 slots, and that means 24 slots, so we can test 24 pieces. If we have to do 1000 hours test, so we block this chamber with 24 pieces. We had to test 100, so we have 5 times 1000 hours, so it's 5000 hours in total. That means we have blocked this chamber just for 208 days just for one test, just for one piece for Volkswagen. And that is, of course, you know, if you have to test the do's not part, that's a huge challenge that will take us busy for some years. Actually, when we lower that, and that is what our R&D right now thinks might be the next, the open, the extended cap ranges. So on the top blue chart table, you see the current offering that we have in that. And for the yellow one on the bottom table, that gives you what is probably be the range if we do this testing and all the tests will pass. So you see on a 6.3 volt side in 1210, you get from 4.7 to 10 mic, same for 10 volt. From 16 volt, 1210, we go up to 6.8 and so on. But you get the table, you can look at that. If you have any question, please ask KEMET sales, our FAE. So we can also prioritize if you have a project and you need that part and you think it might be add value, then please talk to KEMET and then we can prioritize that. Otherwise we start, you know, from top to down. Again, so that's a requirement for application. The German test, because there's a lot of not native German speakers here in the call, we can skip that. It's just saying that we can use this 2 MLCCs, or you can use a floating electrode or open mode or something with flex term. So because not everybody is aware about this KPS, that's the metal bracket, or some other words that going around in the market is megacap, T-bar is also an expression for that. And then you have MLCC with floating electrode, open mode, flexible tension. That's your offering in the 12 volt on 48 volt net. That's the kind of product you can use in there. And I think we have that already. The one thing I would highlight that is it's about, so where KEMET also can help you. This is the prices that I put out from Mouser. And last time I talking about design to cost. So that is something you should probably consider if you're 2 in a row or 2 in parallel. So that is where we can help you. This is Mouser prices for 1,000 pieces because it's very neutral. You can see that on their website. But if you have design that runs in different volumes, so we can talk about it. You can talk with KEMET about, okay, what happens if I buy 2 million instead of 1 million pieces open mode? I can buy 2 million pieces in standard, and then you can see which make most sense for you. Or you have some space constraints, and you can go with open mode because then you list only 50% of the parts compared to the 2.2 microfarad solution. I would really engage you to look for discussion, search for discussion, search for KEMET contact, and discuss with them what will be the best solution in your application. I add this because I think somebody, maybe some newbies here in the code. So what is, when we're talking about this floating electrode, open mode, and flexible termination. So on the left side, you see the floating one. So that the blue one is a floating electrode that's not connected to either side of the chip. The problem is if you are, it's not a problem, but it's a technical given, when you put 2 capacitors in series and you keep the area constant, then you end up with 25% cap. In other words, you have 3/4 capacitance loss. But of course, you have 2 capacitors in series. That means the voltage split up. So the breakdown voltage capability is pretty good on that. If you have a standard part with a certain capacitance voltage case size, and you change it to a floating design, so you have to add 75% layers, and that is I think the biggest cost impact is the stacking of this electrode layers within the chip. So if you put a capacitor, let's say 1210, 100 volt, if you put it in an oven, it doesn't matter if it has only 1 layer or it has 100 layers. The same happens for galvanic. If you put the piece in the galvanic and certain case size, it's always the same workload. But it's the stacking, drying of those layers that makes a difference. So, and a part definitely with more layers cost more in production than a part with less layers. And that's the reason why typically we try for, pure low-cost commercial, we try to use as less layers as possible. For automotive design, we are more conservative because there are some downsides. Then you reduce this, or you reduce the requirements for quality. For automotive, we are more conservative, so we add more layers. And that's the reason why you cannot switch, or you see also the different reliabilities, what I showed in the slide before. Open mode is then you do the active area, and the active area actually means this is dark rectangle here. That's where the electrodes overlap. If you put that outside this blue range, that is what's called open mode. And why it helps? Because the crack always starts here, or you put the force from the other side, in that case from the bottom and here from the top. So you get this kind of crack here. So you still have a crack, but you don't have a short in your application, and that's the biggest advantage of open mode. It's better because you only lose these areas here for capacitance. It's probably roughly 1/3. It's a medium breakdown capability, but of course you need more layers compared to a standard. So the open mode is a little bit more expensive than a standard one. And for flexible termination, that is outside the chip. So you can also combine open mode with flexible termination, or floating electrode with a flexible termination. That's possible, and we offer that as well. So if you want to be safe, then that's definitely an option if you have something that is somehow in regard of safety critical. So, and the next thing, what I'm really happy to announce and promote is that high voltage application MLCC. That's really great. So what the spec is written is, so the rated voltage must be twice, the component voltage must be twice rated voltage, and rated voltage means in that case the board net voltage. In other words, if you go for minimum rated voltage for floating electrode for 400 volt system, 2 times is 800 volts, so the next level will be 1000 volt. And for the 800 volt system, so times 2 is 1600, so the next available voltage class is 2000 volt. We're actually discussing right now 1500 volt because it's gives you a more cap, so less component and some savings, but till today, so that's the rule: 2000 volt for 800 volt, 1000 volt rated parts for 400 volt systems. So that's the offering, because most of you need more than what we offer in one chip. So 1210, 1000 volt, we give you 68 nanofarad, and 2000 volt, we give 6.8 nanofarad. So for the same application, in an 800 volt system, you need 10 times more pieces. Yeah. And so because when you use this KPS system, you can use bigger case sizes. So typically if you need more cap and you don't want to have 200 pieces, probably go down to 50 or 60 pieces, then KPS might be a solution, because we can stack 2 pieces on top. We can use the bigger case size, which gives us more cap per footprint. So for 2220, 1000 volt KPS, that means there's 2 chips on that. You got 240 nanofarad. So 5 of them make nearly 1 microfarad. For 220, 2000 volt parts, so same principle, we can offer you 44 nanofarad. So the safety mechanism is either the KPS, which we recommend, or use a flexible termination as required, which at the moment is not available because everybody has to start testing right now. So the short-term solution will be definitely offering in KPS, and flexible will we take, I don't know, 6 or 9 months, maybe a year from now, until we can get this done. And then we talk a little bit about X and Y caps. That's a German text. So, so let's go for the more explanation slide. So the X capacitor, that between HV plus and HV minus, that has to be 2 flex-term MLCC in 90-degree orientation, or 1 MLCC with floating electrode and a KPS. That's something you can use between. Why? Because if you shorten HV plus, HV minus, I would not be close by here, to be honest. That would be a very, very bad thing. So everything needs to do to prevent this from CX going short that way. That's the reason why you have the two capacitors or this KPS, which makes the chip nearly unbreakable. For the Y capacitor, so that's a life critical thing. So for whatever reason, CY goes short, then you have either HV plus to ground or you have HV minus to ground. And that means if you touch the car, the chassis of the car, you get an electrical shock. And at that voltage level, that is really, really bad and probably will kill you. So for that, it's only two capacitors, 90-degree orientation is allowed, and every capacitor has minimum this 1000 or 2000 volt, depending on the system. So wrap up. For me, Polymer is officially approved on the secondary side of every regulators, less than 5 watt, or less equal than 5 watt. But there are also some exceptions. If you have a kind of limiting or current limiting activities on there. Tantalum is also still allowed. It's not forbidden, but not on terminal 30, but with a reduced power compared to 2.5 watt. And I would go into with Tantalum for energy harvesting, the type pressure monitoring systems, or really something that's this oil sensor or something application. For MLCC, so this reduced test condition that is now given in the latest revision, it will definitely expand the MLCC portfolio. But testing will take some time. So we are in a discussion right now. So we're preparing testing. But you see it's at 2 times 1000 volt, or we're currently checking out our option with higher temperatures. So then we have to take 100 parts, and they have to have special PCB. So we can only have one chip one time in one slot. So we'll slow down the testing, not as fast as we typically work. But we keep you updated. And again, the offer from KEMET is if you want to have a specific part, talk to KEMET sales, talk to KEMET FAEs. We will help you and we will prioritize your request because then it helps us to sell parts easier. And in any case, use FAE to offer application-specific best solution. I mean, that's what we are here, that we are for you, doing for you. And with that, I will give back to Alex.
This means for now, Axel, thank you. We are finished now. Thank you for presenting today and hope to see you soon.
Alex, thank you very much. And also my greetings to all the auditors here. Any question? I think the last slide is my address, so you can send me an email or call me, whatever you want. Oops. Okay.
Okay. Thank you. And it is. Okay. Thank you. Goodbye.
Thank you. Goodbye.